Hello students, welcome to lecture 6 of hydrogen and its compounds. Our topic hard and soft water. In previous lecture we discussed about the water properties, physical properties and chemical properties. Now we are going to learn about hard water and soft water. Now the first one, soft water. What is that soft water? The water which produce good lather with soap called soft water. The soft water will produce good lather with soap, and soft water having low concentration or no concentration of calcium and magnesium salts. The example for soft water is rainwater. Example, rainwater. And next one, hard water. The water which not produce good lather with soap called hard water. The water which not produce good lather with the soap called hard water. And the hard water having high concentration of calcium and magnesium salts. High concentration of calcium and magnesium salts. And hard water forms scum or precipitate with the soap. So the water which not produce good lather with the soap called hard water, and the hard water having high concentration of calcium and magnesium salts. And hard water forms scum or precipitate with the soap. Let me take salts of calcium and magnesium. Salts of calcium and magnesium. Calcium bicarbonate CaHCO3 taken 2 times. Calcium bicarbonate, it is a salt of calcium. And calcium sulfate CaSO4 is a calcium sulfate. And calcium chloride CaCl2, calcium chloride. So these are the salts of calcium. And salts of magnesium, magnesium bicarbonate MgHCO3 taken 2 times. And magnesium sulfate MgSO4 and magnesium chloride MgCl2. So these are the salts of magnesium. If these salts are present in the water, then that water is called hard water. And soap containing sodium citrate, and it react with hard water to give the citrate precipitate, calcium or magnesium citrate precipitate. Sodium containing sodium citrate, it react with hard water to give calcium or magnesium citrate precipitate. Let me take that reaction. Sodium citrate C17H35 COONA in aqueous. So it is a sodium citrate. The soap contains sodium citrate. If you use the hard water contains calcium plus 2 or magnesium plus 2 ions. Let me take M plus 2. Means It may be calcium or magnesium plus 2. Gives rise to, it gives PPT of magnesium or calcium citrate C17 H35 COO taken 2 times and M. So this is the PPT precipitate. If that hard water contain magnesium plus 2 ions, then it will give PPT of magnesium citrate. If the hard water contain calcium plus 2, then it will give PPT of calcium citrate. So due to this calcium or magnesium citrate PPT, the hard water will not give the good lather with the soap. And plus will give Na plus ions, 2 Na plus aqueous, and balance that equation. So here we have to take 2. So here M plus 2 means it may be calcium plus 2 or magnesium plus 2. And the hardness of water is 2 types. One is the temporary hardness and the second one permanent hardness. Let us discuss that hardness of water. So the first one, temporary hardness. The temporary hardness is due to the presence of bicarbonates of calcium and magnesium salts. Bicarbonate HCO3 minus, bicarbonates of calcium and magnesium. The temporary hardness is due to the presence of bicarbonates of calcium and magnesium salts. Already we discussed that the hardness is due to the presence of bicarbonates, sulfates and chlorides. Calcium bicarbonate, magnesium bicarbonate, calcium sulfate, magnesium sulfate, calcium chloride and magnesium chloride. So if these salts are present in the water, then the water is called hard water. Now we are discussing that types of hard water. One is the temporary hardness and second one is permanent hardness. So temporary hardness, the temporary hardness is due to the presence of bicarbonates of calcium and magnesium salts. Means in temporary hardness water, the calcium bicarbonate and magnesium bicarbonate salts are present. And the temporary hardness removed by 2 methods. One is boiling and the second one is Clark's method. A. Boiling and B. Clark's. So these 2 methods are useful to remove the temporary hardness. Means from that hard water we can remove that bicarbonates of calcium and bicarbonates of magnesium salts from the hard water. Let us take that first one, boiling method. During the boiling, the soluble magnesium bicarbonate is converted into the insoluble magnesium hydroxides. So here magnesium bicarbonates are converted into magnesium hydroxides. Is a PPT. And calcium bicarbonate means the soluble calcium bicarbonate is converted into insoluble calcium hydroxides. it is also PPT in the water. So these PPTs removed by the filtration. I am taking that water, means it is a hard water. So this water is a temporary hard water. Temporary hard water. So the temporary hardness is due to the presence of bicarbonates of calcium and magnesium salts. On boiling, what happening here? MgHCO3 taken 2 times. So it is a temporary hard water. In that water we have magnesium bicarbonates. So if you heat it, what happening? The PPT of magnesium hydroxide formed. So it will give magnesium hydroxides. It is a PPT, and plus 2 moles of carbon dioxide. So this is the reaction if you heat that temporary hard water. We will get PPT of magnesium hydroxide and carbon dioxide. Then we can remove that PPT of magnesium hydroxide. So after heating and filtration, in that water, what are the present? Only carbon dioxide. Means in that water there is no magnesium ions. So that water is called soft water. Means here the hard water is converted to soft water by heating. Next one, if that water having calcium bicarbonates, then the water is called temporary hard water. On heating, that temporary hard water is converted into soft water. If you heat that temporary hard water, then it will give calcium carbonate, which is PPT, and plus H2O and plus carbon dioxide. So we can remove that calcium carbonate PPT by the filtration. After removing this PPT, in the water, what are the present? H2O and carbon dioxide. Means in that water there is no calcium plus 2 ions which are responsible for hardness. So this water is called soft water. So here in this boiling method, what happening? I'm taking a temporary hard water. So in that water we have calcium bicarbonates or magnesium bicarbonates. So here I am going to boil that water. What happening? So that magnesium bicarbonate will give magnesium hydroxide PPT, and the calcium bicarbonate will give the calcium carbonate PPT. So that PPT will be removed by the filtration. I am taking that water, then I filter that water. If I filter that water, that magnesium hydroxide and calcium carbonate will stop in the funnel, and the water comes down, which is called soft water, because in that soft water there is no magnesium ions and calcium ions. Next, second one, Clark's method. In this method, lime is added. The lime is added to the hard water. Lime means calcium hydroxide. Lime, the formula calcium hydroxide. So this calcium hydroxide is added to the hard water. Then the calcium precipitated as a calcium carbonate. The calcium precipitated as a calcium carbonate, and magnesium precipitated as a magnesium hydroxide. Then the hard water is converted into soft water, and these precipitates are removed by the filtration as that previous one. Let me take the reactions. I'm taking temporary hard water. So in that temporary hard water, we know that there is a calcium bicarbonates or magnesium bicarbonates. So due to this calcium bicarbonate and magnesium bicarbonate, the water is called hard water, especially temporary hard water. So if you add lime to that temporary hard water, lime means calcium hydroxide. So this is called lime. So here also I am taking lime. Then what happening? The calcium bicarbonate is converted into calcium carbonate, which is PPT, and plus 2 moles of H2O. And here the magnesium bicarbonate is converted into magnesium hydroxide, MgOH, taken 2 times, and plus 2 moles of calcium carbonate. So these are the precipitates, and plus 2 moles of H2O. So these PPTs are removed by the filtration. So here after filtration, there is no calcium plus 2 and magnesium plus 2 ions in the water. So then the water is called soft water. So this is about temporary hardness and two methods for removing the temporary hardness. One is the boiling method and the second one is Clark's method. Next, second one, permanent hardness. So permanent hardness is due to the presence of sulfates SO4 2 and chlorides of calcium and magnesium salts. Actually, the hardness is due to the presence of calcium and magnesium salts of bicarbonates and sulfates and chlorides. So the hardness are two types. One is the temporary hardness and the second one is permanent hardness. So temporary hardness means presence of bicarbonates of calcium and magnesium salts. And now the permanent hardness. The permanent hardness is due to the presence of sulfates, chlorides of calcium and magnesium salts. Means bicarbonates will give the temporary hardness and sulfates, chlorides will give the permanent hardness. And this permanent hardness removed by 4 methods. Number 1, treatment with washing soda. Washing soda formula sodium carbonate. And the second one, calgon method. And third one, ion exchange method. And the fourth one, synthetic resins method. From these 4 methods, we can remove that permanent hardness from the water. So the first one, treatment with washing soda, Na2CO3. The washing soda react with soluble calcium and magnesium chlorides and calcium magnesium sulfates of hard water to give the insoluble carbonates CO3 minus 2. Means here I am taking permanent hard water. The permanent hardness due to the presence of chlorides, sulfates of calcium and magnesium salts. We know that MCl2 and MSO4. So here M means it may be calcium or magnesium. Means here in this hard water we have calcium chloride or magnesium chloride or magnesium sulfate or calcium sulfate. So then that water is called hard water, permanent hard water. So this hard water react with washing soda Na2CO3. Here also Na2CO3. Now when react this washing soda with the hard water, then here it will give carbonates. So here in this we will get MCO3, means it may be calcium carbonate or magnesium carbonate. This is the PPT, precipitate. And here also we will get carbonate, MCO3. It may be magnesium carbonate or calcium carbonate. And here plus 2NaCl, and here we'll get sodium sulfate plus Na2SO4. Here we got PPT. So this PPT is removed by the filtration. Now in that water there is no magnesium and calcium ions. Now that water is called soft water. Next, second method, calgon method. The sodium hexametaphosphate, commercially called calgon. Sodium hexametaphosphate, Na6P6O18. So it is called sodium hexametaphosphate. Commercially it called calgon. So this material is used to remove the permanent hardness of water. That's why it is called calgon method. When it added to the hard water, the complex ion react with calcium plus 2 and magnesium plus 2. Then the complex removed by the filtration. Then we are getting the soft water. So this complex will give the complex ion Na6P6O18. So this calgon will give the complex ion 2Na plus Na4 P6O18 minus 2. So it will give 2Na plus ions. So 2Na plus remaining 4Na. So 4Na and P6O18. So it will give 2 positive ions. Now it will get minus 2. Now this complex ion will react with hard water. So that Na4 P6O18 minus 2 react with hard water. So in that hard water we have calcium plus 2 ions or magnesium plus 2 ions. Let me take M plus 2. M plus 2. M plus 2 means it may be calcium plus 2 or magnesium plus 2. So due to the presence of these ions, the water is called hard water. So here in that water we have calcium plus 2 and magnesium plus 2 ions. So then this complex ion react with hard water, then it will give complex of Na2M P6O18 and 2 minus. So here it will lose 2 Na plus ions. So plus 2 Na plus ions. So this complex is a PPT. So this PPT removed by the filtration. Now in that water we don't have that calcium plus 2 or magnesium plus 2 ions. Then that water is called soft water. So here the hard water is converted into soft water by adding the calgon. So here in this hard water, the calcium plus 2 or magnesium plus 2 are present as chlorides or sulfates. So this is about permanent hardness and two methods to remove the permanent hardness. Treatment with washing soda and calgon method. So the hardness is due to the presence of calcium and magnesium salts of bicarbonate, sulfates and chlorides. Temporary hardness is due to the presence of bicarbonates and permanent hardness is due to the presence of sulfates and chlorides.